Today let us look at decimal expansions. We already know about rational and irrational numbers. Let us recall rational numbers. They are of the form p upon q, where q is non-zero. And irrational numbers cannot be expressed as p upon q. Let us look at a few examples. So 1 upon 8, 7 upon 10, 6 upon 7, 1001 divided by 991 are all rational numbers. And pi is a classic example of an irrational number. It cannot be expressed in the form p by q. Now we do assume pi is equal to 22 by 7 for solving questions, but that is a very close approximation. Pi is not equal to 22 by 7. Pi is an irrational number, whereas 22 by 7 is a rational number. Remember that it is an approximation. Now let us look at the decimal expansions of these rational numbers. Let us look at 5 upon 8. We see that the denominator is 2 cube. Let us multiply both the numerator and denominator by 5 cube. We are using this trick so that we get a 10 cube in the denominator. And we get the decimal expansion as 0.625. It is a terminating decimal. Let us look at 7 upon 25. We could write that as 7 by 5 square. Now let us multiply both the numerator and denominator by 2 square. Now this results in a 10 square in the denominator. And we get a decimal 0.28. Once again, it is a terminating decimal. Let us look at another fraction or rational number, 13 by 40. We could try and factorize 40 as 2 cube times 5 raised to the power 1. Now let us multiply both the numerator and denominator by 5 square. So we get a 10 cube in the denominator. And we get 13 by 40 is equal to 0.325. Once again, it is a terminating decimal. So a rational number in the form p upon q, where the denominator can be expressed as a power of 2 and a power of 5, or 2 raised to the power n times 5 raised to the power m, we have just seen that we can easily manipulate the denominator to become a degree of 10. And this would give us a terminating decimal. Let us look at a few more rational numbers where the denominator does not have 2 and 5. Let us look at 1 upon 3. We see that it results in 0.333 and so on. Basically, we have 0.3 bar. The bar signifies a repetition of the number under the bar. So this is a non-terminating but repeating decimal. Let us look at 22 by 7. We see that it results in 3.142857 and we get a 1 again. So the series is going to repeat. So we get 3.142857 whole bar. Once again, it is a non-terminating repeating decimal. Let us look at 100 divided by 11. We see that the term 09 is going to get repeated after the decimal. So once again, it is a non-terminating repeating decimal. So a rational number of the form p upon q, where q can be expressed as prime factors other than 2 and 5, results in non-terminating repeating decimals. Let us summarize our observations. We see that a terminating decimal results from a rational number p upon q, where q can be expressed as 2 to the power n times 5 to the power m. N and m are positive numbers. We also saw that non-terminating repeating decimals result from rational numbers p upon q, where q is not of the form 2 raised to the power n, 5 raised to the power m. And there is a third category of decimals, non-terminating, non-repeating. These are the decimals that cannot be represented as rational numbers. They cannot be written as P upon Q. All these results are obtained through observation. Let us look at a few problems. Without actual division, show that each of the following rational numbers is a terminating decimal. Express each in decimal form. Let us look at the first one, 35 divided by 50. Let us prime factorize the denominator. We see that it is 5 square times 2 raised to the power 1. So the denominator is of the form 2 raised to the power n times 5 raised to the power m. Hence, it is a terminating decimal. Now let us try to get a 10 in the denominator to express it in decimal form. So let us multiply both numerator and denominator with 2. And we get a 10 square in the denominator. So 35 by 50 is equal to 70 by 100 or 0.7. Let us look at the second part. 23 divided by 2 cube times 5 square. We see that the denominator is of the form 2 raised to the power n times 5 raised to the power m. Hence, it is a terminating decimal. Let us quickly get tens in the denominator. So we shall multiply both the numerator and denominator with 5. And we get a 10 cube in the denominator. So this rational number is equal to 0.115. Let us look at another problem. Express each of the following as a rational number in its simplest form. Let us look at the first part, 0.24 whole bar. Now since we are going to express this as a rational number, let us take that as equal to P upon Q. So here P upon Q is equal to 0.242424 and so on. Now we see that there are 2 places after the decimal that are getting repeated. So let us get these 2 places on the left side of the decimal. So we shall multiply both the sides by 100. So we get 100 times P by Q is equal to 24.242424 and so on. Now if we look at statements 1 and 2 and subtract them, we would get rid of the places after the decimal because they are a non-terminating repeating decimal. So we get 99 times P by Q is equal to 24. Let us cross multiply and simplify. We get P by Q is equal to 8 by 33. Let us look at the second part, 3.24 bar. So we have P by Q is equal to 3.2444 and so on. Now first, let us get the 10th place after the decimal to the left side of the decimal. So we shall multiply by 10. We get 10 times P upon Q is equal to 32.444 and so on. Now let us get the new 10th place to the left hand side of the decimal. So we shall multiply by another 10. So we get 100 times P by Q is equal to 324.444 and so on. Let us subtract 1 from 2. And we get 90 times P by Q is equal to 292. Let us cross multiply and simplify. We get P by Q is equal to 146 divided by 45. We have expressed both the decimals as rational numbers. Let us look at another problem. Classify the following numbers as rational or irrational. In the first part, we see that the terms after the decimal are all different. We have a 04, 004, 0004 and so on. So it is a non-terminating decimal, but it is non-repeating as well. And we know that non-terminating, non-repeating decimals are irrational. Let us look at the second part. It is square root of 21, which is square root of 7 times 3. We could write this as square root of 7 times square root of 3. Now, since both are irrational, It follows that square root of 21 shall be irrational. Let us look at the third part. 3.142857 whole bar. We see that it is a non-terminating, repeating decimal. Hence, it is a rational number.